Hi everyone, I'm Jake, and in my last video I showed you how to make a VR pawn with playspace and character movement and some head-level collision, and today I'm going to show you how to make that multiplayer compatible. By the end of this video, we are going to have the actor's transform replicated, the headset and controller movement is going to be replicated, as well as the capsule's transform and its half height, so you'll have accurate capsule collision between the different players. And to show you the network performance, I ran a test against Unreal Engine's default third-person character blueprint, where I had a default project and network profiled two clients running around the map, and combined, the two of them had an average 0.96 kilobytes per second of network traffic. I did a similar test where I had two of my custom VR pawns moving around on the map with all of these replication things active, and they used a total of 0.72 kilobytes per second between the two of them. So I'm very happy with this. That is game ready network traffic. So let me show you how to do it. I want to thank my Patreon members for supporting this tutorial series. If you want to see me keep making more videos, you want to get access to the project files, early access to the tutorials, and priority tutorial requests, please consider supporting me on Patreon. It would really help me out a lot. Thank you. Alright, so the first thing I'm going to do is go into our custom VR pawn, and I'm going to disable replicate movement, because I don't want to use Unreal Engine's character movement replication system, because it's not going to play nice with our playspace movement. There are ways you can make it work, but there's so many discrepancies between engine versions. I think it's honestly just easier to replicate our movement ourselves. So I'm going to create two new custom functions, or custom events. The first one is going to be called initiate tracker replication. And the other one we need is going to be called Interpolate tracking sources. And so initiate tracker replication, I'm going to trigger on begin play. So I'm just going to have a sequence here. We'll call initiate tracker replication. And then on event tick, we will call interpolate tracking sources. Okay. So on initiate tracker replication, we are going to start a timer, set timer by event, and I'm going to add a custom event, call this replicate transforms. And this is where we are going to send the transforms of our HMD and controllers to the server. We're going to set this to looping, and I'm going to create a new float variable called tracker replication frequency. I'm going to set this to a float. Let's say I want it to replicate 15 times a second, so I'm going to set that to 15, and then I'm going to divide 1 by that value. And so now this replicate transforms event will fire every 15 seconds, and we're going to set it up to send those transforms to the server, because you don't want to send the transforms every tick or super frequently, because transforms are kind of network intensive, and so we are going to just send them like 15 times a second and then interpolate on the other clients so that the movement looks smooth. And we only want to send these transforms to the server if it is the locally controlled client. So I'm going to add a branch node off of initiate tracker replication. And if it is the locally controlled instance of the blueprint, then we will start this timer to send its transforms to the server. So I'm going to create another custom event. And this one is going to be VR transforms to server. And I'm going to set this to run on server. And then we're going to have 3 inputs here. We're going to have our locations, our rotations, and our capsule, the relative value. And so our locations are going to be vector quantize, the vector net quantize variable type, and I'm going to set that to an array because we need 3 of them. Our rotations can just be rotators because Unreal Engine already quantizes rotators as far as I'm aware of. And then this capsule Z relative is just going to be a byte of data. And these rotations should also be in an array. So we'll have 3 locations and 3 rotations. So let's then fire VR transforms to server off of that replicate transforms event, and then quantize our transforms. So I'm going to get our camera, left controller, right controller, and get our world transforms from each of these. Okay. And so for the location, we're going to have to split that struct pen, and we are going to make vector net quantize with our X, Y, and Z. Do that for all 3 of them. And the reason we're using the vector net quantize variable type is just because it's going to save on network traffic. Rather than using 3 floats for a single location, this node specifically is going to quantize it to whole numbers. So we're going to have centimeter accuracy for the location. And then I believe it automatically compresses the rotation to 6 bytes. But don't quote me on that. And then we're going to make an array of these quantized locations and send that to our server. And then I'm also going to make our array of rotations. 0 is going to be our camera, 1 is going to be our left controller, and 2 is going to be our right controller. And then for our capsule Z relative value, that's going to be the Z location of our camera minus the world Z location of our capsule component. And then I'm going to clamp that between 0 and 255. So we can just round it to an integer and then convert that to a byte to be sent through. And that's basically just going to tell us, because on the client side, we are just keeping the capsule positioned directly below the camera or the HMD. And we're already sending the camera's transform, so we really don't need to send that data again. We just need to know, okay, how far below the camera is the capsule? And because that location is also the half height of the capsule, we can replicate the capsule's transform and the capsule's half height and only have to use 1 extra byte. So it's very worth it to get some accurate collision for the other players. Now, operating on the server side, I'm going to promote these to variables. So I'm just going to call this VR locations, VR rotations, and then that can just remain the same as our capsule Z relative. And then I'm going to set all of these variables to replicated. So now we are starting this timer on event begin play. And then, so every 15 seconds, 15 times a second, this replicate transforms function is going to fire, send our locations and rotations and capsule data to the server, where it will set them as replicated variables, and those variables will get replicated to the other clients. And then this is where our interpolate tracking sources function or event comes in handy. So this is only going to fire on replicated instances of that specific client. So I'm going to add a branch node from here, an is locally controlled node, and we are only going to fire this logic if the actor is not locally controlled. So we're going to drag off of the false pin, and I'm going to set world transform of our camera, as well as our left controller and right controller. And what we're going to do here is we're going to use a tinterp2 node, and we're going to get the current world transform of our tracking point, and then we're going to split the struct pin of the target transform, and then we're going to get the information that we saved in these locations and rotations variables. So I'm going to get our locations, get our rotations, and I'm going to get a copy of 0, 1, and 2 for our locations and our rotations. Lovely. So 0 is our camera. So there's our camera location. There's our camera rotation. Gonna leave scale at 1. I'm gonna set delta time to, I'm gonna set interpolation speed to 15, and then delta time can be the get world delta seconds. Okay, and then I'm gonna do the same thing for the left and right controller. So I'm just gonna copy this. I'm gonna move all this to where I've got some more room. This might be something you can compress to a function if you want to be a little bit more organized. I'm gonna copy that, paste it twice. So this will be our left controller. I'm just going to try to organize my nodes a little bit here. That'll be the left controller, and 2 will be the right controller. And then the only other thing we have to set is the capsule transform. Sorry, make sure you get the world make sure you plug in the right and left controller to that get world transform node as well, so that it actually has their current transform to interpolate from. And then we're going to do our capsule. So we actually want to set the capsule transform before we set the tracker transforms, because the trackers are children of the capsule component. And so if we set it after, then we'll end up moving them again out of the transform that we wanted. So I'm going to take our capsule component, set its world transform. We're going to use another tinterp2 node, and we're going to split both locations. So I'm going to plug that in. This is going to get a little bit messy. We're going to have a little bit of spaghetti here, but not too much. So we're going to take our world transform from our camera. We're going to break that because, again, we want the capsule to always be directly below our camera or our HMD. Actually, I'm going to take it from that interpolated value. So this is where the camera is going to be right after it gets set, so it will stay in the same position. So yeah, drag out of that tinterp2 node, break that transform, and put that X and Y into the X and Y for both the current and target location of our capsule. I'm going to once again set our delta time. And I'm going to get the world. Sorry. No, I'm going to get the world transform of our capsule again, because we need the current Z value. We need the current rotation. We're going to leave the rotation. We're just going to plug that into both rotations, so the current and target. And then we just need the target Z location. That's the only other thing we have to calculate and interpolate. And so that Z location is going to be the Z location of our camera minus the capsule Z relative value that we calculated. And then we can plug that into our target Z location. And then from false, set our capsule component transform. And then we're going to set our capsule's half height as well. So I'm just going to duplicate that so it's slightly less messy. Set capsule half height, and that is just going to be our capsule Z relative value. Just like that. I'm just going to make sure everything's okay. I'm going to uncheck update overlaps because we don't really need that. And I think that is everything. So setting the transform of our capsule component and its half height, then interpolating all of our trackers, and that should be it. So let's test this. I'm going to set the number of players to 2 clients. I'm going to press play. I'm going to drag this over here. Okay, so on the right is client 1. And then behind me is client 2. So it's not, client 2 isn't going to be receiving Steam VR tracking data, unfortunately. But you can see on client 1, my camera and controllers are being properly replicated. I can see the controllers over from client 2 being properly replicated, and it looks good. And now I'm going to, I'll show you how to fix that error message in a second. I'm going to check the capsule component first. So I'm going to uncheck hidden in game and make sure that our capsule collision is being replicated properly. So if I go into client 2's line of sight, crouch, you should see the capsule is scaling with me on client 2 as well. So everything is working as expected. All right, now I'm going to show you how to fix this error message. It's just, this is firing before the enhanced input local player subsystem actually exists. And it's also firing on the replicated instances of the client, which we don't want. So I'm going to do 2 things. I'm going to add a branch. So this is only going to fire if we are on the locally controlled instance. And then I'm going to have to add a second branch where we're going to check if this enhanced local player subsystem is valid. And if it's is valid, then we'll add mapping context. If it's not valid, then we'll delay until the next tick until it is. And I'm going to add a print string here just to make sure that does fire. I should get 2 hellos. Yep, there we go. Okay, and I'll delete that print string, and I will clean that up later. So yeah, everything is working as expected. We've got a VR character with character movement and play space movement and collision, and it's multiplayer compatible, and it's game ready. So I'm very happy with how this is going so far. I can't wait to add more features for you. If you want, please comment whatever you want to see me add next, or join the Patreon to get priority tutorial requests. But yeah, I'm gonna just clean up all this code now and package up the project files for my Patreon members. Thank you all for watching. Have a great day. Bye.